All right. So today we're going to be talking about sets. What are sets? Sets are collection of objects. So we can collect objects into a set, and it's a well-defined collection. Yes. For instance, anytime I say, for example, we have a set A, uh, say equal presidents of United States. I don't want to list them because I don't even know them. But in any case, it is a well-defined set. Yes. Why? Because anytime you mention name mentioned to you, and you know that was a president, then you can say this name belonged to that set. Yeah. We can say a set is the name of a month in a year. Yeah. So anybody mentioned next to you, say January, well, January belongs to that set. So it's a well defined. We know what they are. We can well define it by two ways. We can specify what the set is by writing it down. Yes, or we can describe it. We can specify it by writing it down, or we can describe it. For instance, by writing it down, I can say, for instance, A is the set of numbers 1, 2, 3, and 4. So what do I know? We know that we have a set. That set contains each number in there, or each part is called an element. Yes? So we can say 1 is an element of A. Yes? 1 is an element of A. How do I represent to say 1 is an element of A? Oops. So I say 1 is an element of A. Okay? We use this symbol to represent the elements of a set. So we can say 2 is an element of A. We can say 5 is not an element of A. Yes? So 5 is not an element. To say it's not an element, you write the element symbol and you put a line onto it. So 5 is not an element of A. Yes? And then this is one way to describe in A, or represent in A, by listing the elements. Another way of describing A, we can say A is or equal the set of X such that X, yes? And then I have to describe what X is. Yes? What we're saying is A consists of some things. We represent them by X. This symbol over here means such as. We are about to explain what X is. Such as X is a natural number. So now I described what X is. X is some natural numbers, say 1, 2, 3, 4, 5, 6, 7, but we have a whole lot of natural numbers. Yes? We can limit those natural numbers. If I want to describe this set, it is a natural number, right? And that natural number must be less than 5. So now when I specified it, it is less than 5. So now I know natural numbers start 1, 2, 3, 4, 5. Oh, 5 is not included because it's less than 5. So it's only 1, 2, 3, 4. So that describes that set. Okay? So there are two ways, at least right now, we can represent the set. By either listing the element of the set or by describing the set in one way or another. Yes? Any questions on that? No. It says list the element belonging to each of the given sets X such that X is a natural number less than 5, which we already done that. X is a state that borders Florida. So in order to know what that, we look at a state, we see if does it border Florida. If it does border Florida, that means it is part of the set. Yes? I don't know those states, but they're written in the book. It's Alabama and Georgia. Yeah? So if we look at Alabama, it is bordering Florida, so it's part of the set. Texas is not bordering Georgia, so therefore it's not part of the set. Yes? So when we describe it, we have to write a well-defined statement that describes those sets. Clear? So this symbol represents element of. And we only use that for elements, not for anything else. Let's take another set. Let's take a set B is, say, 1, 2, 3, 4, 5. We say A is a subset of B if all elements of A are in B. So now, in order to say or specify A is a subset of B, how do I write that? A subset B. We say A is a subset of B under one condition. That condition is all the elements in A must be in B. So when I look at these two sets, A contains element 1, 2, 3, 4. By the way, I'm sorry, the set has to have a curly bracket, right? And every element is separated from the other element by a comma. So when I look at the elements one by one, say 1 is in A, it's also in B. 2 is in A, it's also in B. 3 is in A, it's also in B. 4 in A, it's also in B. So that means every element in A is in B. We say A is a subset of B. Yes? Now, B is not a subset of A. Why? Because at least there is one element in B that I can't find in A. 5 is in B, but it's not in A, so B is not a subset of A. So B is not a subset of A. Yes? A proper subset, we say A is a proper subset of B if A is a subset of B, but B is not a subset of A. What does that mean? Well, another way of saying this is A must be in B, B doesn't have to be in A. Yeah, we call that a proper subset. A proper subset is represented by the following symbol. Notice the difference between a subset and a proper subset. A subset has like what you say, the equal sign underneath, right? This one doesn't. When we say A is a proper subset of B, that means A is a part of B, but B is not a part of A. In the situation we have, it is. Yeah? A is a proper subset of B because A is in B, but B is not in A. Another way, say A is in B and B is bigger than A. Yes, B must have more elements than A in order for A to be a proper subset. Okay? Now, let's take a look at the following. If A is a subset of B and B is a subset of A. Let's take two sets. Let's say A and B, and I want to make this two sets subset of each other. What happens when I make them subset of each other? Well, in this case, A is a subset of B, correct? Is B a subset of A? No. To make B a subset of A, what do I need to do? Maybe remove 5 from B, or maybe add 5 to A. Yeah? So let's remove 5 from B. Now what happens? A is a subset of B. E is a subset of A. What's the relation between A and B? They're the same, right? So that means A equals B. If A is a subset of B and B is a subset of A, yes, then A must equal B. We clear on that? Given any set, we can create a lot of subsets. Yes? We can create a lot of subsets from that particular given set. For instance, well, this is a subset of that. Yeah? I could say 1, 2, 3 is a subset of A. Yeah? This set is a subset of A. 1, 2 is also a subset of A. Yeah? How many subsets can I make? Let's talk a little bit about subsets. Consider, for instance, I'm going to start with one set. Say A is equal to 1, 2. Just two numbers. Let's figure out how many subsets I can make with those two numbers. First of all, let me introduce a set. This symbol represents an empty set, a set with no numbers in it, yes, with 0 elements. So we can represent that as this, or we can specify it like this. This is a set with no element in it. So those two are equivalent to each other. Yeah? So the empty set is a subset of every set. Yeah? Every set was empty before it even started. Yes? I can make a set with 0 element, it's a part of it. Yeah? So I can say the empty element is a subset of A. Yeah? So let me list them over here. So this is the first subset of A with 0 elements. The next subset of A would be elements contain one, or subsets contain one element. So for instance, I can say the set that contains the one element is a subset of A. Yeah? Because one in here, I can find it right there. I can make another one element set with a 2, yeah? And I say this is a subset of A. I can also, now, that's all the one element I can make. I can make a set contain 2 elements and say this is a subset of A as well. Yeah? Clear? So all of these are subset of A. So how many subset I was able to make? 4. Yeah? 4. We were able to make 4 subsets from a set that contains 2 elements. Let's take a set, say A, B, C. Let's take a set A, B, C that contains 3 elements. So again, to make subsets, we have first one is the empty set. Then we can make sets of 1 element each. So that is A, B, C. Yeah? Those are, again, part of that or subsets of that. We can also make element or sets of 2 elements each. Yeah? We can also make sets of 2 elements each. And we can make a set, and that's all the 2 elements I can make. We can make a set of 3 elements that will be a subset of the original one. Every set is technically a subset of itself. Yeah, every set is a subset of itself. So now, if a set A has an element then A has 2 to the power n subsets. So if A has n element, then A has 2 to the power n subsets. Notice when we add 2 elements, and 2 to the power 2 is 4, we ended up with 4 subset. Yes? As the 3 element, 2 to the power 3 is 8. So we ended up with 1, 2, 3, 4, 5, 6, 7, 8 subsets. Yeah? And so on. Notice something. All the subsets we got are proper subset except the last one. Yeah? What did we say about proper subset? Proper subset is a set inside that, but it's less than numbers, right? All of these are inside A, but they're less in number. This is a 0, this is a 1, this is a 1, this is a 1, that's a 2, 2, and 2, right? Except one of them. One of them is exactly what A is. So all of these are called proper subsets. But this one will be included with the subsets. The difference between a subset and a proper subset. Yeah? A proper subset can be a subset. But a subset does not have to be a proper subset. Yeah? For instance, this one is a subset of that, but it's not a proper subset. But this one is both. It's a proper subset, and it's also a subset. So if a set A has n elements, then A has 2 to the power n subset, and let's say 2 to the power n minus 1 proper subsets. So this is the 3. 2 to the power 3 is 8. We have 8 subsets, but we have 7 proper subsets. If A has 5 elements, then it has 2 to the power 5 subset and 2 to the power 5 minus 1 proper subset. So here we get 32, here I get 31. The proper subsets always less than, one less than the subsets. Okay, now consider the following. Determine how many subsets each one has. So first, let's look at A is equal 1, 2, 3. D equal X such that X is a day of the week. And then C equal the empty set. So how many subsets are there in each of the given sets? To determine the number of subsets, we need to know how many elements in each of these sets. Yeah? Say number of elements in A, call that NA, equal how much? So we have 1, 2, 3, 3 elements. Yeah? So how many subsets does this set have? So number of subsets is 2 to the power 3, which is equal to 8. Yeah? So that will represent how many subsets? The proper subsets are 7. One less. And now let's take a look at B. How many elements do we have in B? So we're looking at a day of a week. There are 7 days of a week, right? So number of elements in B is 7. So number of subsets is 2 to the power 7, which is 128. Yeah? And then the number of proper subset, if we were asked, would be 127. Okay? How about C? What's the number of elements in C? How many? 0. Because C is the empty set, right? Empty set has no element, right? So then, number of subset is 2 to the power 0, which is 1. Yeah? So it is itself. Remember, we said the empty set is a subset of every set, so it is also a subset of itself. So the only subset for the empty set is itself. Yeah? Any questions? Now, anytime you're comparing sets, you use subsets. We say a set is a subset of another or not. Yes? Anytime we're using element, we use the element symbol. So we can say 1 element of X. So 1 is an element in A. Yes? However, Would this be correct? Can I say set 1 is an element of A? No. Yes? Unless A is equal to 1 and 1. Now this is an element. Yeah? But without this, that's not an element. That's a subset. Okay? Just be careful with those. When to use an element, when to use a subset is different. You use the element, the E symbol for all elements. You use a subset when we're talking about comparing sets. Yes? So the E is between an element and a set, and the C kind of symbol is between this one is between two sets. Those sets can be listed or they can be named, whichever way they are. Okay. We use what we call Venn diagram to represent some sets. Let's go ahead and take a look at some kind of Venn diagrams. What do we mean by that? Suppose we have the following sets. The U sets are the numbers from 1, 2 till 10. Now, when you have a dot in between the numbers, that means you will continue at the same pattern you started with, and that's where you end. Yeah? So in this case, we are going the numbers one by one, 1, 2, then the next one will be 3, 4, 5, 6, 7, 8, up to 10. Normally, we see more than 2 numbers. So just to make sure this is the pattern we're looking at. Yes? Let's say set A are the numbers 1, 2, 3, 4, 5. Let's say set B are the number of 3, 4, 5, 6, 7. Yeah? And we want to do a relationship or graph a Venn diagram to represent all of these sets. Yeah? Notice A and B, both of these are part of that. Yeah? So what I'm going to do is I'm going to make a big one over here, and inside it, I'm going to put, because this is a subset of this is a subset of this. When we have a Venn diagram and a set is a subset of another, that graph of the subset will go inside. Okay, so for instance, if this is B and this is A, if I represent A in here, B in here, so A is a subset of B. You know that for sure, right? Because all circle A is inside B. So let's go ahead and use that as whether you want to do square, circle. I like to have my big thing as a square, everything inside it as circles. Yeah. So since U contains all A and B, I'm going to put A and B inside U. Yes? Now remember, when you do a graph or when you do a Venn diagram, you do not repeat the numbers. Inside the Venn diagram or inside a subset or inside a set or what have you, you always have the number written one time. So if I take a set and I say my set is 1, 1, 5, 7, that is not good. Why? Because I have a 1 repeated twice. Unless there is any specific differences, then yes. For instance, if I have A, B, C, that is okay. Why? Because this is a small a, this is a capital A, there is a difference. But here, 1 and 1, there is no difference. So I consider it as one element. So I take that one away. Okay? So you don't want to repeat your elements within a set. So now I'm going to create a circle. Let's go ahead and use some color. I want to create a circle. Let's use yellow and maybe purple to represent each set. So there is a set. This circle, let's say, would represent all the elements in set A. Yeah? And also B will have to be part of U, right? It has to have some element in it, yes? But I did notice that one thing. The raw element belongs to A and B at the same time, right? So that means there is what we call an intersection between them. There are common elements. If they are common elements, that means the circle A and B will overlap. Yes? If all the element in A was inside B, then I'll just put A inside B. But it's not. Only part of it overlaps. So I'm going to overlap part of it. Yes? Now, how do I represent all of these numbers? We know U contains everything. So first, I'm going to start with the circles, A and B. But in order for me not to repeat any, I'm going to start with the common elements between where A and B exist, both of them at the same time. Yes? And everything that belongs to both of them, I'm going to put them in this area. Why? Because this is where A is, and this is where B is. So this area is a common for both, for A and B. What common elements between A and B do I have? A has 3, 4, 5. B has 3, 4, 5. So that means in this area over here, we're going to have the numbers 3, 4, 5. Yes? So now I need to write down the missing numbers from A. If I look at the circle A now, ignore everything else, just look at the circle A, which is this portion over here. This area must contain the numbers from 1 to 5. But this region already contains 3, 4, 5, so I'm still missing 1 and 2. And they only belong to A. So I'm going to put them in the circle where A is, where A alone is. Yeah? Has nothing to do with B. Now for B, again, in here, I should read all the elements in B. What do I have in B? 3, 4, 5, 6, 7. So I do have a 3, 4, 5 already in B. I'm missing 6, 7. So I will put those in there. Yes? Now we're going to go to U, to the set U, right? The set U contains all the numbers from 1 to 10. But I already have within this square, what do I have? We have 1, 2, 3, 4, 5, 6, 7. What are we missing? 8, 9, and 10. So where do they go? They're not in the circle because the circle are for A and B, but they have to be in the square. So the area that's not in the circle but in the square would be anywhere in here. Really doesn't matter. So let's say 8, 9, 10. So now this is a Venn diagram representing those three sets. Okay? Now, let's explain what these are. So we said this portion over here is called the intersection between A and B. And this is how we represent it. A intersection B. This symbol means all the common elements between A and B. Yes? Now, if we look at the two circles together, this area is called the union of those two circles. So that is A union B. A union B are all the elements in A or in B, or both. Yeah? Notice we only count the intersection once. Even though the number of elements in A is 5, the number of elements in B is, again, 5, yes? But the union doesn't have to be 10. Why? Because we only count the common element once. So in this case, the union is 7. Yeah? Now, if I look at the circle A by itself, and I look at all the places outside the circle, everything outside the circle, we call that a complement or a prime. A complement or a prime are all the elements in the big set that are not in A. Yes? So if I look at this, what's A prime? If I look at the universal set, if you want, that's from 1 to 10, I need to exclude 1, 2, 3, 4, 5. So what's left? 6, 7, 8, 9, 10. Yeah? So when you have the word prime in there, that is a complement. Yes? Not the set, but everything other than that. Clear? Any question on that? Okay. So in general now, if I have two sets, and they do have some common element, this will be the intersection. Yes, whatever in there. But if I do have two sets where they don't have any common element between them, we call those disjoint set. So these are disjoint set. And this joint set, the intersection between them is 0. There's nothing there. Yes? The empty set. The intersection between the disjoint set is the empty set. The number of elements of intersection would be simply 0. Yeah? I believe for now, this is all I'm going to talk about. Next time we will continue with chapter 8. And don't forget to do your test. Guys, have a nice day.